Okay, we're going to look at factorizing quadratics. Now, factorizing quadratics is the reverse of expanding brackets. So I'll just start with a reminder of expanding brackets. If you're expanding x plus 3 times x plus 2, you're going to get 4 terms to start with, which can be reduced to 3. So you're going to do x times x, which is x squared. You're going to do x times 2, which is 2x. You're going to do 3 times x, which is 3x. And 3 times 2 gives us 6. We can then simplify it because we've got 2x and 3x. So we end up with x squared plus 5x plus 6. Now before you start trying to factorise quadratics, it's important that you can expand comfortably. Now the opposite of expanding is factorising. So you're taking something and you are reducing it to 2 factors. So we'll do something similar to what we've just done above. So x squared plus 7x plus 12 can be found by expanding to what are called linear factors. Okay, we must have an x and an x at the start to get this x squared term. Now the other numbers, there's conditions on them. The conditions are that they multiply. Let's call the numbers x, let's call them a and b. We're trying to find. So a times b is 12 and a plus b is 7. So it's probably better to start with your 12 and look at the factors of 12. So 12 has factors 1 and 12, 2 and 6, 3 and 4. So they are factor pairs and they all multiply to give me 12. So I'll write that a bit larger on my next one. So the pair that give me the 7 are the 3 and the 4. So my answer will be x plus 3 times x plus 4. So let's take another one. So let's say we're doing x squared plus 8x plus 12. So if we've got 12 again, so we can use the factors that I've already worked out. I'll just write them a bit larger just in case you're looking on a device that's small. So those are the factors. So which pair give us an addition of 8? And it is 2 and 6. So if we factorised x squared plus 8x plus 12, we would have x plus 2 times x plus 6. So let's try a different one then. Let's try x squared plus 10x plus 25. So it will again break down into 2 linear factors. Because we've got a plus there, we'll have a plus here and a plus here. In fact, we have to have a plus there and a plus there to have pluses here and here. But we'll come on to other types later. So if you look at 25, 25 has got the factors 1 and 25 and 5 and 5. So the pair we're going to need is going to be the 5 and the 5. X plus 5 times x plus 5. So on to another. So let's do x squared plus 11x plus 24. Again, not a bad idea if you do use these videos to stop the tape and try the question yourself first and then see if you get the right answer. Okay, so if we look at 24, we can make 24 from 1 and 24, 2 and 12, remember I'm looking for an addition of 11, 3 and 8, and now I've got it, so I don't need to go beyond that. 3 and 8 will give me 11, so it factorises to x plus 3 times x plus 8. So I'm almost running out of paper. We'll have one more on these fairly simple quadratic factorising because I've kept everything positive. Let's factorise x squared plus 12x plus 27. Okay, so again, why not stop the tape and see if you can do this. Okay, so 1 and 27, well that doesn't give me 12, 3 and 9, so in fact numbers that don't have many factors are kind of easier in many ways because you get to, there's not so many factors to look at to find what you want. And so we've got x plus 3 times x plus 9. If you weren't sure of your answers, you could expand your brackets to see if your answer was correct. So I get my x squared on my first, my plus 9x, plus 3x, plus 27, and that would give me x squared plus 12x plus 27. So I know that I'm correct. So that's factorizing quadratics, where both the terms inside the brackets end up being positive, or putting it differently, what we're factorizing has a plus and a plus. In the other videos we'll look at the more complicated versions, where we have pluses and minuses.